He is. It's wonderful. He taught me Spanish in like half an hour. I speak Delaware, for God's sake. I speak Spanish. How the hell are we? Last class. Was it really that late? I got talking. No, I got talking. It's all good. It's all good. And it's all good because we're not going to go the whole day today. That's the thing. I can't imagine you go the whole day today. I had a thought. What's going on now? Week 10. How is it?
Sorry.
No. Ready to be done?
Yes.
Andre's like, yes. I can't tell because he always smiled.
Oh.
He wouldn't pissed. There we go.
Some classes have gone by really fast, like this one. Some of them I can't.
Kind of correct. Most will go by faster because I can't imagine this taking an hour and a half to go through this. Once you see this once, it's funny, I've talked to other educators about the best way to approach this. And they all say, well, they should say they all. A lot of them say, make the kids work through one first manually. I don't think that's a good idea. You're about to see why. Unlike the GOF, which I think was fun, unlike every other test, which is fairly straightforward, this is one of the most convoluted test statistics in existence that I've ever seen. It's gorgeous mathematically. It's also amazingly convoluted. I prepared a kind of a, this is one of those rare times when I actually prepare something to show you, which I hate doing. I like drawing things out of you more than showing you something, but I don't think this is a good idea to have anybody do this manually. I tried it once years ago and in fact fired horribly. But we'll get into that in a second. How's the project? Linear regression.
Oh yeah, I can figure out how to email these things.
Oh boy. There's this class called CIS 70 I want you to take.
Yeah, anyways.
First week is attaching files to email.
No, it's having
Sarcasm. So good.
So did you just
Yeah,
So how was it? Decent? That, again, the reason that project exists as a project and not part of classes, it's too, you see how it's kind of oddball? Maybe you did, maybe you didn't. Did you catch how there were two variables in every single problem? That makes it oddball. It doesn't quite fit the bill. Everything we've been doing is checking one variable. Braking distance. Sure, there are 3 categories, but it's one variable. Braking distance. M&M color percentages. Sure, there's 6 of them, but it's just one thing. It's one percentage. Now you're taking something like heights of one class versus heights of a different class. Or height of a father versus pounds in a son. Or something like that. Very often it's used for data mining. It's used for data mining where you want to see if there's a tie between some variable and some other variable that might not have any obvious relationship. Moneyball, that book and that movie was full of this. That manager, I forget his name now, the manager for the Oakland Athletics, I believe, was the team. He found a correlation between, I'm going to go by memory here, it's probably wrong, number of times a player was able to drive in runs when two men were on. That was the best predictor of success, how they measured success of a player in the major leagues. I mean, like, why the hell would that be tied back to this seemingly obscure data point? I don't know, but it was. And then he went on to use that to get cheaper teams that perform fairly well. So the idea of scatter plots and looking for these regressions is an idea of seeing that pattern that might not be obvious. That's what you just did. Now, some of the data sets were a little bit, silly, like Facebook. I think it was, what was it, Facebook? Easiness factor versus,
You mean rate my professor?
Rate my professor, thank you, Facebook. Rate my professor, easy versus, was it easy? Overall and easy. Seeing if there's any kind of a correlation there. Completely meaningless. Until you realize that some colleges actually look at stuff like that. I actually saw a study about a year and a half ago where they were putting Facebook likes on college and trying to find a correlation between that and the enrollment of the school. Like, is somebody being paid to do this? Because that's asinine. Like that's the most ridiculous thing I've ever heard. Self-selected studies and all kinds of things, just like my profession for that matter. But the other thing is, it opens up these doors because linear regression isn't the only kind. Katie, in 105 we did other kinds. We did quadratic, we did exponential. One of my favorites is called logistic, where you throw a bunch of data points on a graph. And they might not look linear. Because linear regression, somebody asked me an awesome question about linear regression via email. What's the point of using them if you're not going to do predictions with them? Because people get in trouble all the time trying to use them to predict things. They get this beautiful straight line fit on data. And they say, okay, so the data you had went from 2000 to 2010. Let's just extend that line out and see what happens in 2030. That's very tempting. It's also mathematically correct. It's also statistical potential Russian roulette.
Is that kind of like you with your cable bill?
It can be, but my cable bill was
Or
done
internet bill
better.
or whatever.
My cable bill was done better because it's a running average, man. Keeping track as I go. I'm not just taking data that existed for 10 years and assuming it's going to continue in the same way for 20. That cable bill is me tracking it month to month to month to month and seeing if I can tell what's going to happen that previous month, not 20 years out. Because the thing is, you can't assume that your data is going to continue in any given pattern at any given time unless there's some mathematical reason to think that it will. I mean, Ben's population is the perfect example. Years ago, I had to do a study for the Ben Police Department, trying to argue for more funding for the police department, and I was trying to give them a good case. But I couldn't find a good model. None of the models I was trying were working. Logistic didn't work, exponential, logarithmic, nothing like fit the data well. That's because some data just behaves how it's going to behave. It just doesn't, oh, I'm going to be quadratic, time to go back down again. It doesn't know that, it just does what it's going to do. Certain things are fairly straightforward, like human population growth seems to be following what's called a governed exponential, which means we gain, if you look at the United States, for example, it's a perfect example, it gains about 1% population per year. I think it's 1.2% population per year. Now you can't do that forever, can you? Why?
Because we'll run out of resources.
Because you run out of resources, like food, room, hair ties. I mean, you run out of things, right? So eventually what happens is it continues to grow but at a slowed rate, and as soon as that rate slows measurably, it starts to predictably level off. And that's what's called a logistic model. One of my favorites, I didn't bother putting it in your project, because A, Excel can't do it, surprise. And B, if I made you do it manually, kill me. So, you now have a tool at least to get scatter plots done. Please, Renee, go.
Well, maybe this is a question for after class, but the yes or no command in the
Yes.
orange box,
Yes.
if and, what was the significance of 1.96 and 0.47?
You know the answer to that.
Oh, okay.
Don't you? Don't you know the answer of the significance of z equals 1.96?
Oh, fine.
Yes, you do! There's your 95% confidence cutoff. Boom! So if you get beyond that, you become statistically significant. Boom. Does that make sense?
But it's between 0.47
It's
and
tied back because the command has to be able to adjust for both negative and positive correlations, left or right tail.
Okay.
Does that make sense? And again, that particular construct, that r squared value, did anybody get a chance, were you reading the project to kind of follow on what was actually going on with the r squared? It's messy. It's messy, just like this thing is going to be messy here momentarily. But why make you crunch through that if it's messy and just laden with places to go through error? I mean, that's the point. Understanding it is way more important. So that's what the idea is. And it really, all of it goes back to the fact that does it look like a line? That's the big thing, right? I had students for years on that one that was clearly a parabola, putting a linear fit on. I'm like, look at it. It's curving. It's not linear, but it says it's linear enough. It's because it's a dumb machine. Your eyes and your perception is much better. The reason the dumb machines are great is you can look at data and go, I'm not sure if it's linear. It might be. Let me see. Then you could try and say, okay, mathematically it's saying it's linear enough, so that's a little better than my eyes. But your eyes, if they're saying it's not linear, are way better than the machine saying that it is. You saw Anscom's, right? That was that last page. 4 different data sets, all of which had essentially the exact same R. That's crazy. And I think Anscom presented that paper because he was tired of students blindly applying a procedure to a graph without even looking at what they're doing. And that's kind of the point. I've given you a bunch of tools. Thank you everybody that emailed me to post the flow chart. I did. I've given you all these tools. We've learned all these tools together. Now know when to use them, right? Know when the right time is to pop them out. So, blah, blah, blah. So possible. There you go. So that's why it's a project. Hopefully you learned some stuff in there too.